So Ethereum has this massive billion-dollar problem, right? And zkSync is stepping up, claiming it's got the solution. In this explainer, we're going to cut right through all the noise, all the hype, and really analyze the core tech. We'll look at its real-world adoption and its pretty ambitious vision for 2026. And look, this isn't about price speculation. No, this is about the fundamental infrastructure, the stuff that could literally power the future of the entire web.
Okay, let's kick things off with a problem that, if you've been in crypto for more than 5 minutes, you know all too well. Have you ever gone to swap a token or maybe buy an NFT on Ethereum, and then you see the gas fee, and it's higher than the thing you're actually trying to buy? Yeah, that's the bottleneck. That's what's holding Ethereum back from real mainstream adoption, and that is the exact problem zkSync was designed to solve.
So let's really dig into this. What is Ethereum's core scaling problem? It's actually pretty simple. The more popular Ethereum gets, the more clogged up the network becomes, and that creates a huge issue for every single person trying to use it.
The best way to think about it is like this. Ethereum is a single-lane highway, but it's always rush hour. When too many cars try to get on at once, you get a massive traffic jam. And if you want to get through faster, you've got to pay a way higher toll, which is what we call gas fees. The result is the same for everybody. Things move super slow, and it costs a fortune.
So, how in the world do you fix a problem like that? Well, that's exactly where zkSync comes into the picture. It's not about building a whole new highway. Instead, it's like a brand new, super smart layer built right on top of the old one, and its whole job is to clear that traffic jam, hopefully for good. So you hear this term Layer 2, or L2, thrown around all the time. What does it actually mean? Well, just think of it as an express lane built on top of that main Ethereum highway. It takes all the traffic, the bulk of the transactions, and handles them off to the side super fast. Then it bundles all the results together and just reports back the final summary. The key thing to get here is that you get incredible speed and super low costs, but you still get all the security of the main Ethereum network. It's a pretty clever system.
So how does zkSync actually pull this off? Well, it uses this really clever bit of tech called ZK-rollups. Basically, they take thousands of transactions, bundle them up off-chain, and then create this single tiny cryptographic proof. Think of it like a fully verified receipt that gets posted back to Ethereum. But here's the real magic. It's something called the zkEVM. This makes it completely compatible with Ethereum's own code, which means developers can just bring their apps over, like seamlessly. The goal here is simple, really. Make Ethereum fast, cheap, and secure, but without making everyone learn a whole new system.
I mean, when you put them side by side, the difference is just night and day. On one hand, you've got the main Ethereum layer. We know it's slow, we know it's expensive. And then on the other, you have zkSync. It's blazing fast, incredibly cheap, and just as secure because it's still anchored to Ethereum. It's really designed to give you the best of both worlds.
But, the tech itself is really just the beginning. Let's talk about where they're headed. Let's look at their vision for 2026. Because this isn't just marketing hype. This is a serious roadmap for building out some really critical financial infrastructure.
And let me tell you, their roadmap is ambitious. It all kicks off with some major upgrades to speed and security. After that, they're planning to launch something called ZK Porter, which is this system for ultra-scalable data storage. And that's absolutely crucial for any kind of big data application. From there, the focus shifts to deep integrations. We're talking DeFi, gaming, NFTs, the whole shebang. And by 2026, the big goal is to roll out advanced privacy tools and seamless cross-chain payments. This is a very clear, very deliberate plan for institutional-grade adoption.
Okay, but let's be real. A great roadmap is completely useless if nobody actually uses the thing. And any project this big is going to face some major risks. So, time for a reality check. Where is zkSync actually being used right now, and what are the big obstacles standing in its way?
All right, first up, let's look at DeFi, decentralized finance. The sheer speed and incredibly low cost of zkSync basically unlock all these complex financial tools. Think about things like high-frequency trading on decentralized exchanges, or super sophisticated derivatives products, stuff that would be flat-out impossible on Ethereum's slow and expensive main layer.
Next up, we've got gaming and NFTs. These are sectors that are all about high volume. They need to process thousands, even millions of tiny transactions really quickly and really cheaply. So zkSync provides the perfect infrastructure for building out complex games or massive digital collectible projects without that killer friction from high gas fees.
And finally, let's talk global payments.
For big businesses, for enterprises that need payment solutions that are fast, scalable, and can work across different blockchains, zkSync is positioning itself to be a really critical piece of that puzzle. It allows for super rapid, super secure transactions across all kinds of different networks.
But, and this is a big but, the road ahead is anything but easy. For starters, zkSync is up against some fierce competition from other Layer 2s. Not only that, its core zkEVM tech is incredibly complex, which means there could be hidden bugs or performance bottlenecks. It's also completely dependent on Ethereum itself. And at the end of the day, it's in this constant battle to attract and keep the best developers building on its platform.
So on one side, you've got this massive potential. On the other, some really serious risks. And all of this brings us to the ultimate question. How does zkSync really stack up against the competition?
Okay, let's actually compare the major players here. Now, they all use that same powerful ZK-rollup security, so that's a wash. But the key difference, the thing to really pay attention to, is right there in that first row, EVM compatibility. See, a project like StartNet makes developers learn a whole new programming language. That is a huge barrier to entry. But zkSync, along with Scroll and Polygon, they're all focused on high compatibility, and that gives them a massive, massive advantage.
And that right there, that leads us to the most crucial point. This is zkSync's key differentiator. It's offering the absolute gold standard of security, these ZK rollups, and combining it with the ease of use that comes from being fully compatible with Ethereum. Think about it. For the millions of developers who are already building on Ethereum, this is a total game changer. It's a quiet advantage for sure, but a very powerful one.
So when you boil it all down, we're left with this. zkSync has the tech, it has the vision, and it has a really critical strategic advantage with its Ethereum compatibility. It proves that scaling is possible. So the only real question left is about execution. Can they pull it off? Can zkSync actually become the foundational layer for the next generation of digital finance and digital ownership? Well, that's what we'll all be watching.